In the last video, we had seen some key concepts on polynomials. In this video, we are going to discuss some important practice examples on polynomials. If alpha and beta are zeros of a quadratic polynomial, fx is equal to ax square plus bx plus c, then find alpha square plus beta square. Now we know that the sum of the roots is given by minus b by a and the product of zeros is given by c by a for a quadratic polynomial. Alpha plus beta whole square is alpha square plus 2 alpha beta plus beta square. Therefore, making alpha square plus beta square a subject of formula, we get alpha plus beta whole square minus 2 alpha beta. So now we can use alpha plus beta as minus b by a and alpha beta as c by a. So solving, we get alpha square plus beta square will be equal to b square minus 2ac upon a square. Second example. If one zero of the quadratic polynomial a square plus a into x square plus 13x plus 6a is reciprocal of the other zero, then find a. Now suppose if one of the zero is alpha, the other one will be reciprocal, which is 1 by alpha. We know product of zeros years will be alpha into 1 upon alpha, which is 1, and product of zeros is given by c by a, means the constant term upon the coefficient of x square. In this case, it is 6a upon a square plus 9. So actually we have got 6a upon a square plus 9 equal to 1. Solving this, we get a is equal to 3. Now example 3. If alpha and beta are zeros of polynomial fx is equal to x square minus 3x plus k such that alpha minus beta is 1, we have to find constant k. Now alpha plus beta, which is sum of roots, is given by minus b by a. Minus b means over here minus of minus 3, that is 3 upon 1, which is 3. And alpha into beta is given by constant term c upon a, which is k upon 1, which is equal to k. Now alpha plus beta is 3 and it is given alpha minus beta is 1. So adding both of these equations, we get the value of alpha as 2. Substituting, we will get the value of beta as 1. Now alpha into beta is k, which is equal to 2 into 1 or 2. So we have got k is equal to 2. Example 4. On dividing polynomial x cube minus 3x square plus x plus 2 by a polynomial gx, quotient and remainder are found x minus 2 and minus 2x plus 4 respectively. Find gx. Now we have the important relation. Dividend polynomial will be equal to the divisor polynomial into quotient polynomial plus the remainder polynomial. So over here dividend is x cube minus 3x square plus x plus 2. We are not given gx or the divisor polynomial. The quotient is x minus 2 and the remainder is minus 2x plus 4. Now in this equation, we simplify the equation and what we get is x cube minus 3x square plus x plus 2 plus 2x minus 4, which is equal to gx into x minus 2. That means if I want to find gx, what we have to do is we have to divide x cube minus 3x square plus 3x minus 2 by x minus 2. So we will get gx. Now we know the procedure of simple division. It will give us gx as x square minus x plus 1. Example 5. What must be subtracted from fx is equal to x raised to 4 plus 2x cube minus 13x square minus 12x plus 21 so that the resulting polynomial is exactly divisible by x square minus 4x plus 3. Now according to the relation dividend is equal to divisor into quotient plus remainder, which applies to polynomials, we first divide x raised to 4 plus 2x x cube minus 13x square minus 12x plus 21 by x square minus 4x plus 3, and let us see what we get as remainder. Now to get x raised to 4 from x square, we have to multiply it by x square. So x raised to 4 minus 4x cube plus 3x square. Change the sign, subtract it. So we get 6x cube minus 16x square minus 12x plus 21. Now to get 6x cube from x square, we know that we have to multiply by 6x. So multiplying by 6x, we get 6x cube minus 4x into 6x, which is minus 24x square plus 18x. Subtracting, we get 8x square minus 30x plus 21. Again we multiply by 8 and at last we get the remainder as 2x minus 3. Now if we subtract 2x minus 3 from our dividend x raised to 4 plus 2x cube minus 13xy minus 12x plus 21, then we will get the remainder exactly as 0. That means it will be exactly divisible by x square minus 4x plus 3. So we have to subtract 2x minus 3. Practice example 6. If 2 plus root 3 and 2 minus root 3 are two zeros of the polynomial 2x raised to 4 minus 9x cube plus 5x square plus 3x minus 1, then find the other two zeros. Now we know that it is a polynomial of degree 4, so it can have maximum 4 zeros. Since 2 plus root 3 and 2 minus root 3 are the two zeros, x minus 2 plus root 3 and x minus 2 minus root 3 both will be factors of the polynomial. But you know that suppose if 2 and 3 are factors of 6, 2 into 3 will also be a factor of 6. So x minus 2 plus root 3 and x minus 2 minus root 3, when we multiply both of them, it will also be a factor. Now simplifying it, just bring 2 with x. That means x minus 2 minus root 3 and another term will be x minus 2 plus root 3. By applying difference of square formula, a minus b into a plus b is a square minus b square, we get x minus 2 whole square minus root 3 square, a factor. Simplifying it, we get x square minus 4x plus 1 will be a factor. Now since one of the factor is x square minus 4x plus 1, we first divide our polynomial by it. So dividing 2x raised to 4 minus 9x cube plus 5x square plus 3x minus 1 by x square minus 4x plus 1, we get 2x square minus x minus 1. Now obviously since it is a factor, the remainder will be 0, but we are getting the quotient as 2x square minus x minus 1. So when we factorize 2x square minus x minus 1, we get 2x plus 1 and x minus 1. So from the given two zeros, now we have got another two zeros, which will be 2x plus 1 equated to 0 will give x is equal to minus half, and x minus 1 equated to 0 will be giving x is equal to 1. So the other two zeros will be minus half and 1. Some small questions. If alpha beta are roots of x square minus 3x minus 5, then find 1 upon alpha plus 1 upon beta. We know sum of roots alpha plus beta is minus b by a, which here it will be minus of minus 3 by 1 or 3. And alpha into beta is c by a, which is minus 5 by 1 or minus 5. We want 1 upon alpha plus 1 upon beta. So simplifying, we get it equal as alpha plus beta upon alpha beta. Putting the values, we get it equal to minus 3 by 5. Second example, give examples of px, gx, qx and rx which satisfy the division algorithm. We know that the division algorithm is px, which is dividend is equal to gx divisor into quotient qx plus remainder rx. Remember, in these you can give any polynomials of your choice. In the first, the condition is degree of px and degree of qx is same. Now for example, take px is equal to 4x square plus 2x plus 4. Now if I want the degree of qx also to be same, means gx or the divisor should be of degree 0. So let gx is equal to 2 into x raised to 0, which is nothing but 2. So when I divide 4x square plus 2x plus 4 by 2, we get quotient as 2x square plus x plus 2. So here our condition is satisfied that degree of px and qx are same. Remainder will be 0 over here. You can put the values and verify the algorithm. In the second condition, degree of qx should be same as degree of rx. Means the degree of quotient polynomial and remainder polynomial should be same. For example, consider px like we had in the previous case, 4x square plus 2x plus 4. Now if gx is equal to 2x square plus x plus 4, we know that the quotient will be equal to 2. And what will be the remainder in this case? Minus 4. Because when you multiply 2 into 2x square plus x plus 4, we will get the remainder as minus 4. So here the degree of qx and degree of rx both is 0, and that means both have the same degree. Third case, the degree of rx should be equal to 0, means rx should be a constant. The previous example will also suffice. you can take another example also. Let px is equal to x cube plus x plus 4. Consider gx as x square plus 1. Qx will be equal to x, because when you multiply x into x square plus 1, you will get x cube plus x. So what will be the remainder? Remainder will be 4. 4 or x raised to 4 is equal to 4 into x raised to 0, or it will be of degree 0. It is a constant. So Rx is equal to 4 will satisfy degree of Rx as 0. Some assignment examples for practice. Check whether the first polynomial is a factor of the second polynomial. In this, you just divide it, and if the remainder is 0, it will be a factor, and if the remainder is not 0, it will not be a factor. Find the value of b for which the polynomial 2x cube plus 9x square minus x minus b is exactly divisible by 2x plus 3. Again over here, if the remainder is 0, it will be exactly divisible. So whatever remainder you are getting, on the basis of that, you will get the value of b as 15. What must be subtracted from polynomial x raised to 4 plus 2x cube minus 13x square minus 12x plus 21, so that the resulting polynomial is exactly divisible by x square minus 4x plus 3. Again divide it, and at last whatever remainder you are getting, that you have to subtract from the given polynomial, so that the remainder will become 0 and it will be exactly divisible. The answer is 2x minus 3. Find the quadratic polynomial, the sum and product of whose zeros are root 2 and minus 3 respectively. Again use the relationship between the zeros and the quadratic polynomial. You will get it equal to x square minus root 2x minus 3 into k. Now you can get any answer for this. For simplicity, if you consider k is equal to 1, the answer will be x square minus root 2x minus 3. Hope the practice examples were useful. Please do like and share this video and subscribe to my channel Maths Practice. Thank you.